Hello everyone, I am Dr. Millie and today we are going to understand how to draw Lewis structures. So ready for it? I hope you are having a pencil and pen with you because you cannot learn it without doing it on your own. So it's my suggestion that you should keep your pencil and copy with you and do it along with me. Whenever you want, you can pause me. This facility you have. So whenever you want, you pause me, do it on your own and then go for the next step. So step by step, we will be learning how to draw Lewis structures. So first of all, I am going to tell you the rules which you have to follow while making the Lewis structures. The very first rule is select the central atom. So whenever you are making any covalent compound, out of these atoms which are present in that molecule, suppose I am taking an example of CH4. Fine. So you have to draw the Lewis structure of CH4, which is methane. Okay, so you have to draw the structure of CH4. So first of all, I am taking this step. Select the central atom. Central atom means the atom which you have to keep at center and the rest of the atom will be surrounding it. Fine. अब हमें क्या करना है? We have to select the central atom. कैसे करना है? Central atom is that atom which is minimum in number in that particular molecule. So can you see there, this carbon is minimum in the number. मतलब there are 4 hydrogen and 1 carbon. So I will select the center atom as that atom which is minimum in number in that compound. So that is one way that you can select the center atom. Another way to select the center atom is the atom which is having the least electronegativity. तो मतलब जितने भी atoms हैं उसमें से whatsoever is having the least electronegativity will be selected at the central atom. But here we don't have to go for the electronegativity because we can see here there is one atom here of carbon. So I will take the carbon as a central atom. So this is, I have selected the central atom. So this is central atom. Now go for connect the rest of the atoms with the central atom with only single bonds. So अब what we are left with? We are left with 4 hydrogen atom. And the next step is it is written that we have to connect all the atoms with the central atom with only single bond. So what I am doing is I am connecting all hydrogens with this carbon using only single bond. Is it done? So the second step is done. Third step is count total number of valence electron in all the atoms present in that molecule. So how many atoms are there? Carbon and hydrogen. We have to count all the valence electron of all the atoms. So how many valence electrons are there in the carbon? There are 4 valence electrons. How many valence electrons are there in the hydrogen? 1. How many hydrogens are there? 4. So 1 multiplied by 4. That is 4 plus 4, we have 8 valence shell electron. So total valence shell electron we have calculated are 8. Now count the number of, next step is calculate the bond pair electrons. तो कितने bond pair electrons यहाँ पे present है, that you have to calculate. So count 1, 2, 3, 4, 5, 6, 7 and 8. So we have 8 bond pair of electrons here. So bond pair electrons are 8. Okay. The next step is calculate lone pair of electrons. Lone pair of electrons we can calculate using total electrons minus bond pair electrons. So how many total electrons are there? 8 electrons. How many bond pair electrons? 8 electrons. So we have no lone pair of electrons left out. So we don't have any lone pair of electrons in this particular compound. तो अब क्या करना है? This is our structure. We don't need to go for the further steps. The reason behind is if we would have lone pair of electrons, then we have to go for the further step, distribution of the lone pair. लेकिन अभी क्योंकि we are not having any lone pair in this compound, so our structure is already done. So let us find out that the structure is having all the atoms with completed octet or not. Find out करें. So let's see. Hydrogen. How many electrons are there? 1, 2. So this is shared. Hydrogen के 2 electron, 2 electrons, 2 electrons and 2 electrons. One this and one this. On the other hand side we have carbon also with a complete octet. So this way you can draw the Lewis structure of the covalent compound. So this is one of the example. Let's go for the next one, which is somewhat difficult one. So let's take it. Next example I am taking carbon dioxide. So here it is your next example. Okay, so select the central atom here. We can see there oxygens are 2, carbon is 1. On the other hand side, oxygen is more electronegative, carbon is less electronegative. On both the ways, carbon is should be kept in between. So this is our central atom. I am writing it here, carbon. Okay, now connect the rest of the atoms with the carbon. So I am going to connect these two oxygen with single bond with the carbon. Done. Now the third step, that is you have to calculate the valence shell electrons for all the atoms present in the compound. So there is 4 electrons in carbon, 6 electrons in oxygen, and there are 2 oxygen atoms. So it becomes 4 plus 12, that is it becomes 16 electrons. So total number of valence shell electrons are 16 here. Now go for the next step, calculate the bond pair electrons. So how many bonds you have made there? 2 bonds. If 2 bonds are there, one bond is indicating 2 electron. So 1, 2, 3, 4. So bond pair electrons becomes 4. Okay. Now calculate the lone pair electrons. The lone pair electrons are what? Total electrons minus bond pair electrons. Okay. The total electrons were 16. Bond pair electron 4. So it becomes 12 electrons. Now the next step we have to go for, because now we are left out with 12 lone pair of electrons. Now we are supposed to complete the octet of the atom which are surrounding the central atom. So now I have 12 electrons, lone pair of electrons. Now I am going to complete the octet of oxygen, this oxygen first. So let's take it 1, 2, 3, 4, 5, 6. I have given to it 7 and 8. It has already taken. It is bonded with the carbon now. So its octet is completed. So after the distribution of 6 electrons, this is done. So I am going to the next atom which is surrounding the carbon. So that is 6 ke baad 7, 8, 9, 10, 11 and 12. I had 12 electrons and I have distributed all the electrons to the side atoms, not to the central. Central atom will be taken care of at last. Okay? So let's see how we have to complete the octet. Now this oxygen is happy, this oxygen is happy, but what with the carbon? Carbon is not having its completed octet. Now we are going to use next step. And next step says that we have to check whether the octet of the central atom is completed or not. If it is not there, then we have to complete the octet by converting the lone pair of electrons of the outside atoms, converting them into the bond pair. So I am going to give this electron, this bond pair, to this carbon and oxygen in between, and this also I will be keeping in between so that carbon will also become happy. So what I am doing here, look at this. So I am keeping this lone pair here and this lone pair here. So this lone pair is now going to convert into bond pair. तो जैसे ही वो bond pair बनेगा, carbon will also utilize it and that will also become happy. So let's see क्या होता है. This double bond, this side double bond, oxygen, oxygen. There were 3 lone pairs in the oxygen. Now there will be left only 2. 1 lone pair, 2 lone pair. The same thing will happen with this oxygen also. Now let us count the number of electrons inside atoms and in between atom. So look at this. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen done. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen done. Look at the carbon. 1, 2, 3, 4, 5, 6, 7 and 8. Carbon is also done. So this way we made the carbon and oxygen, both of the atoms, happy in this compound. Now the next example is water. So let's take the water then. Which atom I will select as a central atom? Obviously oxygen. So I am keeping this oxygen here. Hydrogen 2. I will connect it with the 2. Okay. Count the total number of valence electrons. 6 and 2 from the hydrogen. 1 from each hydrogen. So total number of electrons 8. Bond pair electrons 1, 2, 3, 4. So this is 4 electrons. Now how many lone pairs are left out? Lone pairs will be 8 minus 4. So 8 minus 4, that is 4 electron. I have to start by looking at the octet of the side atoms first and then I will go to the central atom. So can you see there is an exception here. Hydrogen, in case of hydrogen, we cannot give any lone pair to the hydrogen. क्यों नहीं दे सकते? Because hydrogen is the smallest atom and it cannot have more than 2 electrons, which already it has completed its octet. So we have to go directly to the oxygen. So I am going to keep all the electrons, lone pair electrons, to the oxygen, because my side atoms are hydrogen and hydrogen cannot have lone pair of electrons. So I am keeping my lone pair here. So this is the structure of water. I hope it is done. Now I am taking one more example along with this, and that is ammonia, NH3. NH3, let's take the central atom, okay, which is the smallest in number. So I am taking here nitrogen, and then I am connecting it with 3 of the hydrogen with only single and single bond. Hydrogen, hydrogen and hydrogen. Now we have to count the number of valence electron total. So this is 5 electrons in the outermost shell of nitrogen and 3 from each hydrogen. So 5 plus 3, 8 electrons total. Okay. Now the next step is see how many bond pairs are there. 1, 2, 3, 4, 5, 6. So total bond pair electrons are 6. Okay. Now what is left out? Lone pair of electrons. Lone pair of electrons are total minus one pair. So total 8 was there minus 6. So how many electrons are left out? 2 electrons. I cannot keep my lone pair here on the hydrogens because hydrogen cannot have lone pair. So where I am going to keep my electron? Here. So this is the structure, Lewis structure of ammonia. I hope you are understanding now that how to make the Lewis structure. I hope it is easy and it is interesting also. I hope you are learning it also. Now we will go for some of the examples which will contain positive charge and they may contain negative charge. So let's do it. So first of all I am taking first ionic species, and that is H3O+. Okay. So do remember, whenever you are talking about the plus and minus, you have to count the total number of valence electron considering this charge present on this species. Now one thing you have to take care when you are dealing with the species which are having some charges on them. What is that? When you are calculating the total number of valence electron, that time you just make sure that if there is positive charge, it means that it has lost one electron, there is lacking of one electron. तो आप उसमें से reduce करिएगा. Like if I am talking about this species, how many electrons are there in the oxygen? 6. How many electrons? 1 in each hydrogen. So I am taking it 3. And what is their charge? Which type of charge is there? Positive. It means what? It has lost one electron. है ना? So what I am doing? I am subtracting 1 from the total number of electrons. Because definitely it has lost 1 electrons. That is why it has acquired positive charge. Fine. Now what is left? Now we are left out with 8 electrons. So total number of valence shell electron in this species is 8. Now do the same procedure. So what is the central atom here? Oxygen. How it is connected with the hydrogen? Like this. And what will be the number of bond pair? Bond pair number of electrons? 1, 2, 3, 4, 5, 6. है ना? तो how many electrons are there? 6 electrons. So bond pair electrons are 6. Okay, so lone pair electrons will be 8 minus 6, that is 2 electrons. So I will have one lone pair of electron here because I cannot have this lone pair on the hydrogen which are surrounding species. Otherwise our priority would be the surrounding species. So I have kept one lone pair here. Okay, now what to do with the plus charge? Plus charge कहाँ लगाना है? Whenever any atom is having the bonds more than its usual state, means we know that if it would be oxygen, simple oxygen, the configuration becomes 2, 6 electron. That is why it has tendency to make 2 bonds. This is the general way how the oxygen reacts. ठीक है? कैसे? By taking 2 electrons or by making 2 bonds. Now just because you can see here that oxygen is making 3 bonds. Can you see? Oxygen is making 3 bonds. What does it mean? It means it is looking for the 3 electrons. और ऐसा कब होगा? It will happen only when 1 electron of the oxygen is lost somewhere. So that is why the positive charge will appear on the oxygen. On the other hand side, if you don't want to understand it, you can understand one thing. Whenever there is a positive charge, that will appear on the central atom always. And whenever it is acquiring the negative charge, it will always acquired by the species which are surrounding the central atom. Okay, I hope it is clear. Now let us make one more example. And our next example is ammonium ion. All of you can see again we are having one positive charge on the species. If there is one positive charge, I will just subtract one electron from the total number of valence electron. Let's do it. So nitrogen ke how many electrons are there? 5. Hydrogen say I am getting 4, but just because there is a positive charge on this species, I am reducing 1. So what is left out? 4, 5 plus 4, 9 minus 1, that is 8 electron with the ammonia. The rest of the things will remain same, that is I am going to connect this nitrogen with 1, 2, 3, 4 hydrogens from all 4 sides. Okay. Now the next step is count the number of valence electrons. You have counted it. Count the number of bond pair electrons. 1, 2, 3, 4, 5, 6, 7, 8. Means bond pair electrons are 8. So lone pair electrons will be 8 minus 8, that is 0. That is why there is no lone pair electron present on the nitrogen. Now what is left out? Where we have to keep the charge. As I told you, in normal circumstances, nitrogen ka configuration is 2, 5. If there would be 5 electrons, it might have bonded with the 3 atoms. So in the normal circumstances, it bonds with the 3 of the atoms, but in this condition it is attaching with the 4. It means इसका एक electron कम है, and that is why the plus charge will appear on the nitrogen, and this is the Lewis structure of nitrogen. I hope you are understanding this now. So let's take one example of the negative species, and here it is CO3 2 minus. So let us start making it carbon. Carbon, because it is less in number in this particular ion, so I am taking it as a central atom. So here it is carbon connected with 3 oxygen in all 3 directions, and 1 bond I will be making between all. Total number of electrons, valence shell electrons, I can count 6 3s are 18 plus 4 electrons from the carbon and 2 electrons I will add because this is negative ion. So I am adding 2 electrons. So the total number of electrons, valence shell electrons, are 24 electrons. Now I have to count the bond pair of electrons. 1, 2, 3, 4, 5, 6. So bond pair of electrons are 6. Lone pair of electrons we can calculate 24 minus 6 electron, and that becomes 18 electrons. Now we have to distribute all these electrons to the oxygen atom at the present at the surrounding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So there are 18 electrons in this carbonate ion. Oxygen is done, this oxygen done, this oxygen done, and this is done. 6 plus 2, 6 plus 2, 6 plus 2. Now look at the carbon. 1, 2, 3, 4, 5, 6. 6 electrons are there with the carbon. So what we have to do is, we have to now utilize this lone pair to make the bond pair, so that the carbon will also complete its octet. So I am doing this. I am removing this lone pair and converting it into bond pair between the carbon and oxygen. Now our structure is completed. The carbon is having 8 electrons in its outermost shell. Every oxygen is having its completed octet. Now where to use the negative charge? Because this carbonate ion is having 2 negative charge on it. In this oxygen we can see 1, 2, 3, 4, 5, 6, 7 electrons are there in the outermost shell of oxygen. और होते कितने हैं? Oxygen is 8 and the configuration is 2, 6. So there must be 6 electrons in the outermost shell of oxygen. But here we can see the 6 are there. So what is shared here? If the 6 electrons are there in the outermost shell, it means there is something wrong, and this has taken 1 electron from somewhere else. So this will acquire minus charge. Then only it is possible for the oxygen to have the 7 electron in its outermost shell. Na? So this is done. And the same way 1, 2, 3, 4, 5, 6, 6. So यही हो गया. So what is being shared? So this is an extra electron which is present on the oxygen. So these two electrons will be occupying oxygen, which are bonded with the carbon with a single bond. As I have told you, if any, just note it down, इसको लिख लीजिए आप, that when any atom make the bond less than what was required by it in usual states, that means it is having minus charge. And when an atom makes the bond more than in its usual state, it acquires positive charge. Okay? So this way your carbonate ion is this. I hope it is clear. Now move to the next one. I am taking now this time nitrate ion. So let's make it nitrogen, 5 electron, oxygen, 6 electron. How many oxygens? 3 oxygen. So this is 5 plus 18 plus 1 electron. So this becomes 24 electrons. So total number of total valence electron are 24, and the nitrogen will be connected same way. So nitrogen, oxygen, oxygen, oxygen. Okay, how many bond pair? 1, 2, 3, 4, 5, 6. So 24 minus 6. Lone pair of electron, how many lone pair of electrons are there? 18 electrons. Now start distributing all the electrons to the oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now let us see whether all the atoms are satisfied or not. So let's see to it. 1, 2, 3, 4, 5, 6. Nitrogen is having only 6 electrons. So what to do now? We have to use this lone pair to make it satisfy. So I am removing this lone pair electron here and I am using this to make the bond pair. Fine. Now this is done. Is it done? No. One thing is left out. What is that? Now we have to use the minus charge on any of the atom. And now as you can see here that there is only one minus charge. So I am allowed to give only one minus. But you can see here that one minus will come on this because this is connected with the one bond, and one minus will appear on it because this is also connected with the one bond. Okay, so both the oxygen will get the minus charge. So how this nitrate is having only one minus? Let's find it out. So what is the condition for the nitrogen? Can you see the nitrogen is making 4 bonds, and in normal condition how it makes? It makes only 3 bonds. And if it is making more than should be there in the normal state, that means there is a positive charge on the nitrogen atom. So can you see there, one positive and one negative is nullifying each other, and what is overall charge left out with the nitrate? 1 minus. That is why there is 1 minus on the nitrate ion. I hope you have now understood that how to make the Lewis structure of the covalent compounds. It is easy and I hope you must be enjoying it also. In the next part of this video, I am going to tell you some more new rules so that you can go for the difficult structure also along with the formal charge concept. Formal charge concept which will help you to understand which Lewis structure out of the possible structure will be more stabilized and which one is correct one. So in next video we will discuss about the formal charge. We will discuss some difficult molecules. Okay, so if you like the video, please hit the like button, share it with your friends, and please comment in the comment section. Thank you very much.